Chemical nomenclature. Let's start with ionic compounds. Ionic compounds are composed of a metal and a nonmetal. The anions, the nonmetals, add IDE to the element name. BaCl2 is barium chloride. K2O is potassium oxide. MgOH2 is magnesium hydroxide. KNO3 is potassium nitrate. For transition metal ionic compounds, we must indicate the charge on the metal with Roman numerals, since there can be more than one charge. Look at FeCl2. The two chlorides make the iron 2+, so we write iron 2 chloride. FeCl3, we have 3 chlorides. The iron is 3+, it's iron 3 chloride. Cr2S3 makes the chromium +3, chromium 3 sulfide. Here's a table showing some common monatomic anions according to their positions in the periodic table. Group 4A, the carbon group, is carbide, etc. Group 5A is nitrogen group, nitride. Group 6A, the oxygen group, oxide. Group 7A, the halogens, fluoride, chloride, bromide, and iodide. Here's an important table of common inorganic cations and anions. It's important to look at not only the name, but also the formula and the charge. You have to memorize all three things, especially for the polyatomic anions. Molecular compounds are composed of nonmetals or nonmetals and metalloids. They often use common names like water, ammonia, and methane. The rule is the element furthest to the left in a period and closest to the bottom of a group on the periodic table is placed first in the formula. If more than one compound can be formed from the same elements, one uses prefixes to indicate the number of each kind of atoms. The last element name ends in IDE. The table to the right shows the prefix and the number corresponding to the prefix. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Here's some examples of molecular compounds. HI, hydrogen iodide. NF3, nitrogen trifluoride. SO2, sulfur dioxide. N2Cl4, dinitrogen tetrachloride. NO2, nitrogen dioxide. N2O, dinitrogen monoxide, often called laughing gas. An acid is a substance that yields hydrogen ion when dissolved in water. Hydrogen chloride is a gas. If it is dissolved in water, it becomes hydrochloric acid. Here's a table of some simple acids that are commonly used. An oxoacid is an acid that contains hydrogen, oxygen, and another element. HNO3, nitric acid. H2CO3 is carbonic acid, and H3PO4 is phosphoric acid. This table shows the relationship between oxoacids and oxoanions. The name of the oxoacid changes with the number of oxygens. Let's look at an example with chlorine. HClO4, perchloric acid. Losing an oxygen, HClO3, chloric acid. Losing another oxygen, HClO2, chlorous acid. And finally losing the last oxygen, HClO, hypochlorous acid. A base is a substance that yields hydroxide ions when dissolved in water. NaOH is sodium hydroxide. KOH is potassium hydroxide. And BOH2 is barium hydroxide. Industry uses sodium hydroxide to peel potatoes and fruits like peaches. Hydrates are compounds that have water molecules attached to them. BaCl2 with 2 water molecules is barium chloride dihydrate. LiCl with 1 water molecule is lithium chloride monohydrate. MgSO4 with 7 waters is magnesium sulfate heptahydrate. SrNO32 with 4 waters is strontium nitrate tetrahydrate. The picture below shows copper sulfate pentahydrate, and then removing the 5 waters by heating, we go from blue to almost an off-white, the anhydrous copper sulfate. Here's some common names and some systematic names of compounds that we encounter every day. Organic chemistry is the branch of chemistry that deals with carbon compounds. It depends largely on functional groups. This compound has a hydroxide ion, making it methanol. It's an alcohol. This compound has an amine, methylamine, commonly used in shampoos. And this one has a carboxylic group. This compound is known as acetic acid. Acetic acid is the active component in vinegar. Here's a list of organic compounds known as alkanes. They are hydrocarbons containing only carbon and hydrogen, and the first 10 of them are shown here. They're all singly bonded. We're going to do a whole chapter on organic chemistry in the second semester, and we'll go over all of these in detail.